What's going on, everybody? Welcome back to another video of mine, where today I will be talking about implicit differentiation. And just like we know explicit differentiation, I bet that's what we're all used to. And so let me just start off by telling you the differences between implicit differentiation and explicit differentiation. Explicit differentiation, which is pretty much what we're all used to, like I said, that's where you have y on one side and x factor on the other side of the equation. All right, so when it comes to implicit differentiation, this time we can have both x terms and y terms on either side. Okay, so that's the only difference there. But other than that, solving the problem is pretty much the same way, okay, as we're going to see. Now let me just give you a little guideline here of how we're going to solve this problem right here. All right, so the first thing we're going to be doing is differentiating both sides of the equation with respect to x. And then after that, we'll be able to collect level-like terms involving dy dx on the left side of the equation and moving all the other terms on the right side of the equation. All right. Then after that, we can factor out dy dx out on the left side of the equation. And then after that, we can be able to solve for dy dx. Okay, by dividing both sides of the equation. All right. So let's not waste any time. Let's jump right into it. Okay, so the first thing I'm gonna do is just, take the derivative. All right, so the first thing, as we know, when taking the derivative, we'll make sure you drop down the 3 in this case. So you're gonna have 3y, make sure there's a squared right there, so we subtract 1, okay? And then this is gonna be dy dx. All right, so we're done with y cubed. Plus, take the derivative of y squared, that's gonna be 2y dy dx. All right, then the 5y is just going to be 5 dy dx. All right, then when it comes to the x squared, since it has no y term, so we're just going to take the derivative of it, like the way we do it in an x term. So that's going to be just 2x. And that's going to be equal to the derivative of -4. The derivative of any constant, as we all know, is 0. So I'm just going to indicate that as a 0, okay? So in this case, we have a dy dx in this term, dy dx, and a dy dx. So that means we can factor it out. Pull it out, dy dx, and then what you're left with inside the parentheses is going to be 3y squared, which is this term, plus a 2y, which is this term, minus a 5, which is this term right here, okay? Close the parenthesis, minus a 2x must give us a 0. All right, so what's the next thing? Keep in mind, all we want to do is just end up with dy dx on one side, all right? So in this case, I would just say dy dx, parentheses, 3y squared plus 2y minus 5. Then I'm going to send this -2 on this opposite side. And when I do so, it's going to change the sign. It's just going to be positive. All right. So that's what we end up with. And then after that, all I'm just going to do is divide both sides by what is inside the parentheses. Okay. Such that on the left-hand side, I just have dy dx being equal to 2x over, okay, 3y squared plus 2y minus a 5. And there it is. There we go. It's nothing complicated. It's just basically taking the derivative as you would do it in a normal x term equation. All right, everybody, so that is it. I just wanted to give you a brief idea of how to do such problems. Once again, implicit differentiation. If you do have any questions, if you do have any problems with this question, just feel free to comment below. And don't forget to like my video. And once again, thank you for your support. And see you on the next video.